Hi again, and today's session is on conditional statements and loops. These two constructs are important for directing the flow of our program and automating some of our programming statements for repeated execution. So we'll be starting with conditional statements. A conditional statement uses the terminology if, else if, and else to direct the flow of our program, depending on if certain conditions are met. These conditions can be if a variable is equal to a value, or if it is more than or less than a value in particular. So let us start with the basic use of a conditional statement. We can prompt our user to input their age, and then depending on if their age is more or less than a certain value, we can output two different statements. So let's go ahead and implement this. So I'm going to clean up my code here, because we're no longer using this. This is from our previous session. And let's say std out, please enter your age. Put my end line here. And let's make an integer here, int age. And remember, we're going to initialize our integer here to prevent the compiler from putting a random value in it. And let's say stdcn age. And then we're going to actually start writing our conditional statements here. So let's say if age is more than 18, let's output you are an adult. And notice here that when I started my if statement, I had if. Then I open my normal brackets and I put my condition in between these brackets here. So I'll say if age is more than 18, and then I open the curly parenthesis brackets here to indicate this is the body of my if statement, and I have a closing one to indicate the end of the body of my if statement here. And I put my instructions inside it to say you are an adult. Else you let's output another line here, say you are still a child. And the same thing with the else here is that I need to use the parentheses brackets in order to indicate the body of my else statement. Now, in this case, I have age being more than 18, but what happens if we are actually 18 itself, and 18 in most places are considered to be adults? So we say if age is equal or more than, or we could say more than equal to 18. So that way, if we put 18, we will get the adult statement as required. So let's build our program here and start with our debugging. And we have please enter your age, and let's say we put 18. Let's say you are an adult. If we rerun our program here and we put something less than 18, so let's say 7, you're still a child. In the instance where if we didn't have this more than or equal to here, and we left it as more than 18, and let's rebuild our program and start with our debugging. And if we actually put 18 here, you see it's going to output you're still a child, because we didn't consider for when we're actually at the value of 18. That's why we need to put more than and equal to in this particular case. So if it was like 18.01 or something like that, yes, it's more than 18, but at the actual value of 18, it's still going to consider this not being more than 18. So that's why it's important to put these more than and equal to or less than and equal to signs when you're doing your if-else conditional statements. So for a simple use like this, where there are only two decisions to be made, it is basically if the condition is met, you follow this particular part of the program for the if statement. And if it is not, you follow the other part of the program flow, which is going to be for the else statement. If more than two different program flows are required here, this is where the else if statement comes into play. So let us modify our existing code to include 3 different program flows instead of the 2 that we have already implemented here. So let's say if our age is more than 18, we say we're going to output you're an adult. And instead of that being just being more than equal to and that, let's also say if our age is more than 18 here, and we're going to put two and symbols here to say, okay, this is going to be and age is less than 21, or less than equal to 21. Okay. You are not a full adult yet. Else if, and we're going to put this else if right underneath our if statements. And we open up parentheses brackets here to put the body. And we're going to say else if age more than equal to 21. I'll put here, you are an adult. And we're going to leave our else statement here as is to capture any other conditions that we didn't cater for. So we have if age is more than equal to 18 and if age is less than equal to 21 here. But this is also encompassing the value of 21. So maybe we want to put this as age less than 21. Because for our next condition here, for the else if statement, we have age more than equal to 21, which already encompasses the value of 21 here. So let's build our program. And then start with our debugging. And let's try for our three conditions here. So let's put a value less than 18. So let's say 12. Still a child. Start with our debugging again. And let's put a value in between 18 and 21. Let's say 20. You are not a full adult yet. For argument's sake, let's put the value of 21 here. So we're supposed to see you're an adult. Right, and you get you are an adult. So because we have more than equal to 21 here, and we know 21 is basically the adult age for most things in particular, that's why we output you are an adult here. If we left this as less than equal to 21 here, we would have gotten two statements being outputted here. And let's illustrate this in particular. So if I left this here as less than equal to 21, and let's rebuild our program and start with our debugging. And if I put the value of 21 here, you'll say you are not a full adult yet. So we won't even get to the second part here. We're just going to get this part here where you're just literally not a full adult yet. And that's wrong in our particular case when we're trying to implement this. So that's why we put less than 21 here. And then we have more than equal to 21 here in particular. So in a use like this, the else if statement allows us for us to check for different individual conditions, and the else statement is used for all other conditions that were not explicitly checked. So you need to take particular care when you're illustrating these conditions for your if, else if, and well, the else in particular as well, because you need to make sure that when you're specifying your ranges, you don't have any overlap. These ranges need to be distinct in nature. And as we saw when we had less than equal to here for age, and then we had more than equal to here, instead of the two executing, we just only got the first one executing in particular. So that's why you need to put less than 21 here, and then more than equal to 21 here in particular. So moving on to loops. A loop is basically an automated way of repeating certain statements for a certain number of times. The simplest loop construct is the while loop, and let's see about how we can actually implement this in our code. So let's get rid of this if-else statements that we just loaded, and let's say while I need to define my value here. So int I is equal to 0. And let's say while I is less than 11. For arguments, let's say I is starting at 1. So while I is less than 11, expressing our condition here for our loop, and we put the curly parenthesis brackets to indicate the body of our while statement. We want to output the value of I. And then we want to say I is equal to I plus 1. And let's build our program here. and stop it on debugging. And we can see here that we actually have a program counting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it stops right before we hit the 11 value. So instead of me copying and pasting the same instruction 10 times to output the value of I, and also incrementing it, which will also have to be copied and pasted 10 times as well, and this is going to be very tedious, I can just implement this repeated instruction here using a while loop. Furthermore, if I wanted to change the number of times this loop runs, all I need to do in my code here is just to change the condition for when the loop ends. So let's say instead of 10 times, let us modify our loop to run for only 5 times. And that means here, instead of being I less than 11, this now is going to be I less than 6, because we want to go from 1 to 5. And we know what I here starts at 1. So it's going to start at 1 here. It will output the value of 1, and then it will go here and increment by 1. So it's going to I plus 1, so it's going to the value of 2. And when it reaches the value of 2, it's going to go back into the loop here and check, okay, is it still less than 6? Yes, it is. And it will keep on going until this value of I here is more than 6. And once it's more than 6, and it's like, okay, is I more than 6 here? Yes. Okay, we no longer need to execute this loop, and we can just exit out and go to the next instruction right after it. So in this particular case, we're going to see that our loop is going to execute only 5 times. So let's build our program and stop it out debugging. And we can see here we go 1, 2, 3, 4, 5. And that's our expected output as required. So the other type of loop that is commonly also used in C++ programming is the for loop. Its construct is a little bit different from the while loop since it incorporates all the conditions up front before execution. So let us observe an example of it here. So we're going to do the same thing where we're going to be counting up to 10. And let's say we go to a 4, and then we open on all the brackets here to specify our conditions. Int I is equal to 1. I less than 11, and then we say I plus plus, and we're going to open a curly brackets here to indicate the body of our for loop here. Now I plus plus here in this construct is the same as I plus 1, so I'm just going to put a comment here. I plus plus is the same as I equal to I plus 1. And we're going to output the value of I here to see what's going to happen when we run our program. And we're supposed to see the program here counting from 1 to 10 as it's supposed to be expected. So let's build and stop it out debugging. And we can see here that we get the same output as when we did for the while loop. We go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we finish our program here as expected. So let's explain this in a little bit more detail. So the for loop here, when we specify our conditions here in between our normal brackets, we have our starting condition, which is I equal to 1. Our condition that we need to check to make sure that the loop keeps on executing. Once this condition is no longer met, the loop stops executing and it goes to the next instruction right outside of it. And the change in condition to make sure that we don't trap ourselves in our loop and we just keep on doing the change in condition for each iteration or each instance of the loop. So this here is going to be I plus plus, which is basically the same as I equal to I plus 1. Which is very similar to when we did the while loop where we had I equal to I plus 1 inside of it to keep on changing the value of I until we no longer satisfy the terminating condition here, which is going to be I less than 11. So the same result is going to be obtained whether we use the while or for loop, and it really comes down to preference when it comes to which one to use. Similarly, let's say if I wanted this for loop here to run only 5 times, I just need to change this condition at the start of the loop here, and we can achieve the same results. So the same way that we had I less than 6 for the while loop, we just put I less than 6 here for the for loop, and we rebuild, and we stop it out debugging, and we can see here that our program just only counts from 1, 2, 3, 4, 5 as expected. Now let's see what happens when we implement a loop inside of another loop. This is also referred to as nested loops in C++. We'll be using two loops that count to 5, and for this example, we'll be using unique loop variables to keep track of the count inside of the loop so we can observe the effect. So we're going to have for our initial loop here for int I equals 1, I less than 6, I plus plus. And I'm going to put another loop here. So for int j equals 1, and we're going to use the same conditions, j less than 6, j plus plus. And we're going to move our cout statement here for I. I'm going to put this inside here. And we're just going to put some additional stuff here so that we can see what it is. So we can have the I value here. And then we want the j value as well. And let's just bring this up one line. So what we're going to see here is what's going to be the current value of I for each iteration of these loops, and what's going to be the current value of j as well for each iteration, or for each instance of the loops. So when I say iteration, it basically means each instance of the loop. So let's build our program here and start with our debugging. And let's see what it looks like here. Okay, so my cout statement needs a little bit more cleanup, so let me X this off and make this look a little bit nicer. I want to rebuild. Start with our debugging. Alright, so here we go. So we can see here, nested loops operates such that the inside loop does all the counting for each iteration of or instance of the outside loop until the condition of the outside loop is met, and then all the loops here are finished executing. For this particular case, the nested loop runs a total of 25 times, which is 5 for the inner loop multiplied by 5 for the outer loop. So let's actually watch this manually here from the output that we generated. And we can see here that for the first instance, I here is 1, and then j here is 1. But then for the second instance, I is still 1, and j here is 2. Then I is still 1, j here is 3. I is still 1, j here is 4. And then I is 1, and j here is 5. So because j here has completed its run, being 1, 2, 3, 4, 5, I here being initially at a value of 1, now increments or goes up by 1 value here to 2, and then j repeats itself going 1, 2, 3, 4, 5, and then I here will increment by 1 being 3, and j will keep on doing the same thing, and then 4 will go 1, 2, 3, 4, 5 for j, 5, 1, 2, 3, 4, 5, and then because both here reach a value of 5, they no longer satisfy the terminating conditions here. So I is going to be more than 6 here, and j is going to be more than 6 here, and both loops basically finish executing as required. So nested loops, we just watch the terminating conditions, see, okay, it's less than 6, so it's going to run 5 times for the outermost loop here, and less than 6 here for the inner loop, so it's going to run 5 times, and we just multiply those two limits to figure out how many times in total both loops are going to operate for. So that's it for today's session. In our next session, we'll be dealing with two new data structures which are known as array and strings. So until then, take care, be safe, and see you soon. Later.